All right, everybody, I wanted to make a couple of videos here, starting here with our Unit 7 that we're still in. Unit 7, Lesson 3. We are on page 63 in the book, or 65, sorry, 65 in the book. All right, and then I'm going to see what I can do here, guys. I don't know what the plan is online-wise, so hopefully this helps. Just try to your best to pay attention. And then you can always pause and replay things or whatever. All right. Again, it's math, so sort of listen, follow along. You should be fine. All right. So the NC State Fair Planning Committee is still working on plans for the children's barnyard. They need to rebuild the barnyard using new dimensions. In order to begin, the committee will start with a duck pen. Let X represent the dimensions of each side of the duck pen, as you can see. Now, remember we did adding and subtracting polynomials first. So we've already done that. That was talking about perimeter. All right. And so remember, this is from lessons 1 and 2. We focused on perimeter, which was adding all the sides up. And then we had some problems where we had to subtract. And so we've done that already. Now, remember with adding and subtracting, pretty straightforward stuff. You can only add and subtract like terms, something like this. So if I'm adding or whatever, again, perimeter is all the sides, so typically we would have more things, but you would just add like terms, okay? So since I'm adding, nothing really happens here. Remember, with subtraction, the signs change. So this would give me 8x, and then 2 minus 7 is negative 5. And then subtraction, let's see. Something like this. Remember with subtraction, the signs will change. This is where some of you guys were messing up on. Remember, the signs are going to change everything. So this is going to make minus 4x. This is going to make a minus 3. You notice the subtraction goes into this, and then this sign is what I get. All right, I don't have a double sign here. So when I combine like terms, this and this combine to give me negative 6. And then this and this combined to give me negative 4. So that would be my answer. All right. So that's what we did with lessons 1 and 2. Perimeter and then, subtraction, of course. With those. All right. Just a quick recap. All right. But now getting into this, we're talking about area. Okay. So area of the duck pen. What is the area of the duck pen? This is question 1. So for square and rectangles, the area is length times width. And so what we're going to do here is we're using the dimensions of the duck pen. We're going to multiply x times x, and then that simplifies to x squared. Now, the reason why it goes to x squared is because you take your exponents and you add them. 1 plus 1 is 2. So when you're multiplying like bases, you add the exponents. Okay, and that's going to be the answer that we get there. All right, so this is our expression for the area of the duck pen. All right, number 2, we're going to draw a diagram to represent this. As you can see, I've sort of pre-drawn some of it already, or this diagram, to represent the area of the cow pen. It says the duck pen is where we start. It starts the same size as the duck pen. So if you notice, I kind of redrew that. It's not perfect. But it is increased by 4 feet on one side and increased by 3 on the other side. Increased by means we're adding, okay, not multiplying. We are just adding 4 feet to this, okay, increased by. So this is our cow pen. This is how big our cow pen is. Now, to find the area of that cow pen, remember it's length times width. So length times width, length times width. So that's going to be this side times this side. All right, now, how do we go about multiplying this out? Okay, so what we're going to be using is the distributive property. But you're going to distribute everything from this parentheses into this one. So that means we got to distribute both this x and this 4 into this parentheses here. Okay, now, I typically draw some arrows here to show what I'm going to multiply. So I'm going to distribute x times x, which remember x times x is x squared. Then I have to distribute here. So if you notice, I'm distributing everything. Okay, so then x times 3, that is 3x. And then I go 4 times x, so now I distribute here. Remember, everything is going into there. 4 times x is 4x, positive. And then 4 times 3 is 12. Now I'm going to combine like terms. So that's going to give me this and this, so 7x. And that's my area of the cow pen. So this expression, both of these expressions represent the area. This is just the multiplied out version of that. Okay, so that's kind of what both of these are. So both of these expressions represent the area. This is just your simplified, multiplied out answer. Okay, so both of these work, but that's kind of what this unit's about. All right, let's look at, this video might be kind of long, so we'll see. And maybe what I'll do is I'll do maybe a question here or so, and then I'll bump over to the others, and then you guys can work from there. All right, so continue to find the dimensions of each pen by drawing a diagram and writing expressions given the following scenarios. Use x to represent the length of the sides of the original square. So the sheep pen is increased by 7 feet on one side and increased by 2 feet on the other. So increased by so it's going to be x plus 7, and then increased by 2 feet on the other side, x plus 2. And then we have to find the area of that. Okay, so length times width. Okay, now, remember at the end of the day, that's all we're doing, length times width. So we're going to multiply, so we're going to distribute this out again. Okay, distribute. Okay, so we're going to go x times x, x times 2. If you take your time, you'll be fine. All right, if you take your time, you will be fine. And make sure you get everything done, draw your arrows, you should be fine. Okay, so then I'm going to go 7 times x, and then 7 times 2. And so there's my next step. I'm going to now combine like terms. And that is the expression for the area of this. Okay, so remember, this is just an expression. That's multiplied out. So this is an area expression as well. I just multiplied it out to get here. So both of these are the same. Okay, so sorry, my dog barks at everything. All right, so both of these are the same, just or equivalent. I'll use that word. Let me erase that. Yeah, because they're equivalent to each other. They're not the same because they look different, but they are equivalent to each other. Okay, so both of these are representatives of this area here. Okay, all right. Now let's look at the goat pen. The goat pen is increased by 5 on one side and increased by 3 on the other. I draw all my rectangles the same, but you can draw them differently. If you want to draw it like this, that's fine. Doesn't really matter, right? Same thing, right? So this doesn't matter, all right? So whichever way you try to do it, it's fine. All right, but when we do the area, multiply them together. Again, these are equivalent expressions. What I mean by equivalent, let me go back up here real quick. So if you have something that says 12 times 3, well, 12 times 3 is 36. And so equivalent, when I multiply these two together, I get 36. So this and this are equivalent to each other. They're equivalent. So this here is equivalent to this here, okay? It's just me multiplying this out, getting this expression. So it's like me multiplying this together to get this expression. So that's what equivalent means, all right? I just want y'all to see that example, all right? It's just me trying to explain what that means. All right, so you can get rid of that though. This has nothing to do with the problem. I was just trying to explain. All right, when I multiply this one out, okay, going through the same steps, guys. At this point, most of you probably can get this relatively easily now. Again, draw your arrows, keep up with what you're doing. And then combine like terms. You have to make sure you simplify this. And then we get to there. Okay. All right. Now, using your dimensions, find the area of each new line as the product of length and width. All right. So I've sort of gone through and done step number 4, problem number 4 already. I just felt like it sort of worked together. The product of the length and width, we've already done that. So that's what this answer is here. So these answers, this work that I've done goes with number 4. Okay, so everything I did here goes with that. So we've already done this. Okay. Oh, let me get my video to. All right, there we go. Okay, so I've already checked this off. Now, if x is 5, what would the area be for each pin? Now, remember, we talked about this in lesson 2, or actually lesson 1. X is actually just the length of the fencing, pre-made fencing. So if the fencing was 5 feet each, like each section of fence was 5 feet, what would the area actually be? So what I can do is I can start off with the duck pin. So remember, if we go back, the duck pin is that. All right, so it's going to be x times x for the duck pin. If x is 5, then I'm going to substitute in, all right, and get 25. Or I can just say 5 squared. Because remember, with the duck pin, I multiply that out, and I got x squared from that, right? So both of these are the expressions for the area. So both of these are fine, and then my answer would come out to 25. So it'd be 25 square feet. Okay, so that's for the duck pin. Now, when I go to the cow pin, remember, we went through, we got x plus 4 and then x plus 3. So I'm going back and looking at that. Okay, so my cow pin area, x plus 4, x plus 3. Then what I would do is I would substitute 5 in for that. right? Or I could go into the other expression, right? The other expression is this one. So I could go into this expression, x squared plus 7x plus 12, and substitute in for that. And what that expression was, remember, was me multiplying out all of this to get my answer there. All right. Now, as I go through this work here, this would be 5 plus 4 is 9. And then 5 plus 3 is 8. 9 times 8 is 72. All right. And so once we get to that point, we have our area of the pen. But if I do it this way, I should get the same answer. This is 25. 7 times 5 is 35. 25 plus 35 is 60. 60 plus 12 is 72. So if you notice, I get the same answer because they're equivalent. Remember, equivalent. So that means both of these, even though they don't look the same, they are representative of the area of the same image, the same picture. And so these are equivalent. Their values are equivalent or the same at the end of the day. Okay, so that's what we have there. Now we have our sheep pen and our goat pen. And so what I'm going to do is kind of give you those answers. And then you can always verify your work once you get there. So if x is 5 and I go into these, my sheep pen is going to be 84 square feet. And then if I go to my goat pen is going to be 80 square feet. So if x is 5 and I plug it into these two, then that's what my area would be. All right. Now, the last thing, all right, going in, this is the last part here. So the NC State Fair realized that some of these pens were going to be too big, way too big for the State Fair grounds, so they decided to redo each pen in the following ways. So basically what they're doing now is they're introducing how you can increase one side or decrease another side. And so, again, it honestly doesn't matter how you draw it. So one side is being decreased by 3. The other side is being increased by 5. So just sort of pay attention to the wording here, increased by, decreased by, okay? Now, in terms of the area, you would multiply those together and then go through the same steps, okay? Go through those same steps to get your answers there, okay? So this would be x squared positive 5x. But now this is the issue that we get to, is people not paying attention to signs. Negative 3x, so minus 3x, negative 15 when you multiply those two together. Okay, remember distribute, which means we're multiplying. Okay, so then the area comes out to x squared. Combine like terms, I get 2x and then minus 15. Okay, so this is my area for this figure. All right, and then we go through those same steps, guys. All right, go through those same steps. Now, I'm taking care of number 7 by doing these parts right here. So this part right there is number 7, okay? So this is what I got from number 7 down here, okay? Just letting you know, okay? It says the product of the length and width, so that's why we're multiplying. All right, And then these, I'm just going to sort of set these up. Increased by 7, and then decreased by 2. This one here, decreased by 5, and then decreased by 3. And then you just go through your steps and multiply those out. I'm going to let you do that. You do the work. All right, so I'm gonna leave that blank. I would say pause it, but I just wanna make sure you try the work and see if you can get to this answer. So you're gonna multiply all this out, and then your final answer is gonna be x squared. You gotta go through your process, which is that. For this one, I will show the work. I would say pause it to try. And then I'm going to go through this work real quick. Okay, so pause real quick, try it out, and then come back. All right, so now that you're back and tried it, hopefully you got this right. I'm going to multiply this. So x times x is x squared. X times -3 is -3x. -5 times x is -5x. And then -5 times -3, negative times negative, positive 15. So when I combine like terms, I get x squared minus 8x plus 15. Okay, so hopefully you got this right. Okay, so good stuff. All right, so your homework will need to be to go through the ready, set, go, and practice this. Okay, remember you're multiplying this stuff out. So this is 3 times x. So it's going to be 3 and then x squared. Remember x times x. Okay, and then 3x times 7. 3 times 7, -7 is -21. But you cannot forget the x. Okay. All right. And then sometimes you don't have to multiply at all. You just combine like terms. So just combine like terms. Here, this has nothing to come with it, so it just comes down. And then you do these there, okay? Don't forget with subtraction, you have to distribute. I showed you that at the beginning. And then here you are distributing, taking x into this parentheses. All right. And then you're taking x, negative x, into this parentheses. So that's going to be -3x squared, and then -x into this, -8x. And then you combine like terms. And then this 1x minus 8x is minus 7x. Okay, and this would be your final for this one. Okay, so go through and try these. All right, for the set, it'll tell you product of, right? Product means to multiply. So F and G. So you're going to say F times G. And then you're going to multiply it out, okay? So you just have to take your time, go through, and multiply that out, all right? Same thing over here in this section. This means to multiply. All right. So, and then your go is just using this graph and answering these questions. What does it represent? All right.